Hello, and thanks for joining me for this presentation on advanced data acquisition for cardiovascular hemodynamic assessment. My name is Brandon Boucher, and I'm the Research Product Manager and Support Manager at 80 Instruments in North America. What I'm going to be taking you through today is a little bit of a background on how to analyze your data. We've already gone through a presentation on the basics of data acquisition, how to acquire data, the importance of acquiring quality data, and what to look for during recording and what you might want to see when you're doing that. What we're going to take you through now is what to do after you've acquired that data. You already have your data now. And what are you going to do to handle that data, and what are you going to do to report on the various parameters that you're going to be interested in for this discussion? So the first thing we're going to do is take you to a little bit of an overview. So first, we're going to talk about blood flow. There's a couple of ways we're going to analyze blood flow here, so we're going to talk about that. Next, we'll talk about pressure, then pressure volume, and then we're going to tie it all together using the analysis manager. The data pad is a tool we use for all kinds of data. The data pad is a spreadsheet program. You're going to find this in all data acquisition systems just about. And what it's intended for is a custom tool that you can use to define your own data analysis. And that's typically what we use to do the analysis for blood flow data. And that's how we're going to display it for you today. But it really can be used for anything. We also use a secondary tool in specific instances where you're looking for a certain subset of things for blood flow. We'll also use peak analysis to automate that analysis a little bit easier. It's going to give you some specific parameters, and we'll show you how to do that as well. The next thing we'll talk about is automating analysis for blood pressure. For all of these parameters, really what we're going to try and focus on during this presentation is what's important to look for, whether it's artifacts, getting rid of those artifacts, and ensuring that the data that you're going to end up reporting is going to be as high quality as possible. So we're going to look for that when we're talking about blood pressure. And then we're moving on to pressure volume. We bring in that volume signal from that ventricular pressure volume. And how do we analyze that? What are we looking for? What are the specific areas we want to analyze? And that type of thing is what we're going to be discussing. And we're going to be using the pressure volume loop analysis tool to do that. And then lastly, we'll be looking at the analysis in LabChart. But the point of talking about this part of the software that you're going to be using during the course is to take a look at the importance of keeping your information in a place where you can always access it. Months or even years after you've acquired and analyzed data, it's important to be able to go back and reach back to the raw data and take a look at it and make sure that everything you've done in previous experiments is what you really need, and that's what we're going to be taking a look at with the analysis manager. So what I'm going to do now is switch over to LabChart. So here we are looking at the blood flow data that we used in the previous presentation. In the previous presentation, we took a look at the raw data in the blood flow channel. We analyzed it and tried to get a cardiac output measurement using the smoothing channel here in channel 1. I've added a couple of channels to this. There's heart rate here in the channel below, and there is also a volume measurement or stroke volume measurement here in this channel. What I want to take note of, though, is there is a difference between this file and the file we used previously. In the file previously, I had calibrated the aortic flow in liters per minute. In order to better analyze this data, I calibrated it in liters per second to make it a little bit easier for the analysis tools to transfer from liters per second into liters, which is how we're going to get our stroke volume or our cardiac output measurement. So in order to do that, really, I just changed the calibration. I changed the calibration value from 10 liters per minute to 1.666 liters per second. And now to analyze this data, we're going to use the spreadsheet program or the data pad. And to use that, or to use the data pad, what we're going to try and do is set up the columns to ask for the information we're interested in. By default, the data pad asks for the mean of every channel. Instead of doing that, we're just simply going to ask for the mean and maybe the standard deviation of a few of these channels that are specifically interesting to us, namely the cardiac output channel here in channel 1. We'll be looking at the heart rate channel as well as the stroke volume. So next, what we're going to do is set up the data pad. So you'll notice that there's already numbers here, and those numbers come from the selection that we've currently made. If I make a selection in the chart view, the datapad updates and shows us that information. So to change what each column is asking for, what I'm going to do is click on the top of each column, the column header, and here I can clearly define a different set of analysis for each column in the datapad or the spreadsheet. Here it's asking for statistics, mean of that minute volume channel, which is exactly what I do want in this column. Next it's asking for the mean of the aortic flow channel. I don't really need that. What I'm going to be doing here is switching that to get the mean of the heart rate, and then the next column I'm going to be getting the mean of that stroke volume channel. If I want to, I can ask for standard deviation, or I can ask for maximum minus minimum. I can ask for a number of different parameters here. There is a huge number of things that the spreadsheet program and the datapad will allow you to acquire from your graphical data. But we're going to focus on those three main things here, so I'm going to turn off the rest of these columns. And this is what we're really interested in, is the mean from each of these channels. Now the next thing we need to find out is where do we want the data to come from. So the way the datapad works is if I make a selection, column 1 shows me the current selection. I can make that data permanent in the datapad by clicking on Add to Datapad. And now I have that data for the area I've selected. But I may want to be a little bit more robust in terms of where that data comes from. So over the course of this experiment, you can see that there was a compound addition that caused an increase in both heart rate as well as your cardiac output. So maybe I want to compare the differences to the baseline and the values afterward, and maybe I just want certain time segments for the entire data file. So what I'm going to do is show you another way of doing this. You can of course make your selection for any area you want and add that to the datapad. Oop, wrong button. Add that to the datapad, clicking that button here. But next we're going to show you how to automatically add a number of data points to the datapad, and that's using multiple added datapad. So what I'm going to do is add multiple data points. Perhaps I want a 3-second average through the entire data file. And that's what I have. If I click on any of these points, or double click on any of these points, I can see where that data came from. So you can see that the data up here toward the top came from the early data, and the data down here toward the bottom came from the data after the compound addition. And this is a very easy way for you to report on changes in blood flow. So what I'll do now is close the datapad and take a look at the other way to analyze this data. We'll use the peak analysis module to do that. And we'll go to settings. The peak analysis settings will allow us to detect each of the waveforms that we're interested in analyzing. You can see the detector has gone through and detected each of the blood flow waveforms in the aortic flow channel. We have some options to ensure that we're doing our best job of detecting each of these waveforms. Generally, the sine shape will do a pretty good job with blood flow, so we'll keep it there. We also have a minimum peak height adjustment. You should recognize this. We were talking about cyclic measurements in the prior presentation. This will look pretty familiar to you if you were looking at that. The other things you have the ability to do here in peak analysis is take a look at how the baseline is defined. So the baseline would be the area before the blood flow peak begins to start. We can also do some custom calculations. So this area allows you to define those custom calculations. And those custom calculations, as well as the standard calculations, will all be listed here in the table options. The table options allows us to choose which parameters we're really interested in. So we have information like the peak area, which will give us our stroke volume. We can do the amplitude of the peak, and perhaps we want the time of the start of each blood pressure peak, and then we can get the width at 50% as well. We can get any one of these parameters that we like. We'll keep it simple for this presentation, but you can go through. If you hover your cursor over each of these, you can see what the parameter is that you're getting and whether or not it'll be relevant to the analysis you're trying to accomplish. If I click OK, you can see that the analysis tool has gone through and detected each of the blood pressure peaks. Next, we'll open up the other windows available to us in this automated analysis tool. So here we have a table giving us the data of interest, and here we have an analysis view showing us each of the waveforms. If I click around on my table, you can see that both the analysis view as well as the chart view update and show me the waveform that I've selected and give me an idea about what that looks like. What I'm then going to do with this is take a look at the peak area value. The peak area value will be my stroke volume, and that's really the most important parameter when we're looking at the automated analysis of blood flow. I, of course, can then take this data and I can export it as a text file, which will make it very easy for me to bring all of that data from multiple animals and multiple groups together to do my data analysis further in another software. I can also go back to the settings from this point as well. Last but not least, if I really want to, what I can do here is I can do a channel calculation based on the analysis that's been done here with the automated analysis tool. So instead of using cyclic measurements, I can get a channel which gives me the same information in a slightly different way. So to do that, what I did was click on the volume channel and I clicked on peak analysis, and I'm going to display the peak area. So pretty straightforward way of doing the analysis. It's a little bit more automated and allows us to get data quickly and very easily outside of the program here. What I'm going to do next is we're going to open up another file and we're going to talk about how to analyze blood pressure data. So my blood pressure data, I'm going to open up this file, and we have both a ventricular and an arterial pressure. We do have the PV loop module, which allows you to analyze ventricular pressure, but it's really designed to have the volume mixed in there as well. So using the blood pressure module specifically to analyze the data for blood pressure is really the way you want to go. So to analyze this data, we're going to go to my settings. You'll want to make sure again that each of the blood pressure waveforms is identified and identified only once. You'll choose your source channel, make sure you got the correct channel. You can choose at this point to analyze the entire data file, or you can analyze a selection of data. Analyzing the entire data file makes it a lot easier to do a large bit of data. Analyzing selection allows you to really compare two different areas. Perhaps you're adding a compound and you want to compare one area before the compound addition and one area after. You'll choose what type of signal you're analyzing. And then just like some of the other analysis tools, your minimum peak height here will allow you to detect smaller peaks, or perhaps if you've missed some of these with a detection protocol, you can adjust that accordingly. You have some options for your tau parameter, whether you want an intercept or not, and then you also have an option to find the end of diastole from an ECG signal if you'd like. Lastly, you can also average cycles in the blood pressure module, and the reason for that is because over a long study you may not be interested in what's happening on every heartbeat. You may be more interested in what's happening in batches of data. That's pretty much all there is to the blood pressure module. What we're going to do is click OK, and then you have the important parts here. First, you have the classifier view, you have the analysis view, and you have the table view. So let's take a look at each of these. So first we're going to look at the classifier view, and the reason we're going to look at that first is because that's going to allow us to do what we need to do to get rid of any artifact that might be present in the data we're taking a look at. So if I click on some of these points in the plot, the chart view will update and show me that particular point. Now none of these are really artifacts, all of this is great data, but if this were an artifact, what I could do with this is remove it from the analysis. And you can see that this one here turned red, and it's no longer going to be used in our analysis. Once we're finished and we're comfortable that there's no more artifacts in the data, what we'll do is take a look at the table view here. The table view will give us all the information we're interested in. If you click on options, you can see which parameters have come out of this. And then just like the other module with peak analysis we're talking about, you can export that data to your spreadsheet program of interest. So the key thing here is that what we want to do is we want to analyze that data, ensure that all of the beats have been found, and then we want to make sure that if there's any artifacts, we will have removed those from the data analysis. Next, we're going to talk about what to do with your pressure volume data. Pressure volume data is legitimately more complex than both blood pressure or blood flow, both in terms of data analysis as well as the results. The results you get from pressure volume are much more comprehensive than what you're going to be getting from the other applications, and therefore there's a little bit more involved with doing the data analysis. To start off, we're going to use this pressure volume data. You'll recognize this as coming from a transonic pressure volume system. And what we're going to do is first start by going to the PV loop module and opening up the workflow. The first step is simply to set up the workflow based on what your application is. So we're doing a small mammal. Pressure is in channel 1. Volume is in channel 2 in this case. So you want to choose the channels that your pressure is in and the channel that your volume is in. Now, the workflow in the PV loop module is designed to work with both the molar pressure volume system as well as the transonic pressure volume system. And we're going to be using some transonic data here, but I'll briefly go through the rest of the parts to the workflow in PV loop here. The workflow in PV loop gives you the opportunity to do your pressure calibration from within the PV loop workflow. So you're going to be starting from the beginning. Normally, if you're recording this data, you'll start off with the workflow open, choose your settings. You're able then to do your pressure calibration and your conductance calibration. So in the case of the molar system, we'll first calibrate into units of millisiemens or RVUs before we transfer that data over to microliters. With the transonic unit, the system will be sending units of microliters directly to LabChart, so we won't have to use these portions. But these portions are here if you are using the molar pressure volume system. Going through these other settings here, we'll click on sampling. This gives you a little bit of instruction, but essentially is the portion where you'll begin recording data and acquiring the data necessary to do your analysis. And if necessary, with the molar system, you'll also go through the cuvette calibration. This is where you'll be dipping the catheter into the cuvettes and applying the conductance measured to a known volume. You do your saline calibration, and again, if necessary, the alpha calibration. So there's a few more calibration steps when we're using the molar pressure volume system, and those are built into the workflow mode as well. The important part here for our discussion, though, is the Analyze section. So clicking on Analyze allows us to analyze the data. I'm going to select a section of data here surrounding my baseline content. That's the area we designated that we wanted to analyze. And normally you're only going to select 10 loops or so. You can do a little bit more than that, a little bit less than that, but it really just you want a section of data representative of the area you want to analyze. And because we're analyzing baseline data, we'll choose baseline here. We'll click Analyze Now. And you'll see that all the parameters we were interested in have populated into the hemodynamics table, and we also have the loop view available to us for a couple of purposes. The loop view is really intended for us to be able to remove artifacts and also review the loops themselves. So if I click on these loops, you can see that the loop 1 that I've clicked on here has been highlighted in the chart view. It's also been highlighted in the loop view here in blue. And lastly, it's also been highlighted in the table. And so you can either discriminate in the loops based on the shape, simply looking at these. Typically the artifacts we'll be looking for here will be the respiratory artifact. It's pretty common when you're recording pressure volume data. We'll see a respiratory artifact, and we may want to remove 1 or 2 loops associated with that artifact. If you do find one that's artifact, now none of these here really we can say are artifact, but we'll choose one. This one here is smaller than the rest, and so if we do designate that as an artifact, we can remove it from the analysis by clicking the checkbox here. What's left for us is a loop by loop analysis all the parameters we will want from pressure volume. If we click on options, we can see that all the parameters are here. What you'll want to do here is just make sure that only the parameters that you really want to have are selected. So I'll choose stroke work, stroke volume, cardiac output, some key parameters, ejection fraction, and tau. And based on what I want to do in my analysis, I'll choose the parameters that I'm really interested in for my baseline data. Now that I have this here, of course, I can export the data and export that as text, so you can open it up in your other programs to do your statistical analysis. And essentially we're ready at this point to use this baseline data and move on to other sections of data. Another important aspect of this, though, is we'll want to use this data later on. Perhaps after we've done our statistical analysis, we may want to add a parameter, or we may want to do something with this area that we've analyzed in each data file. So what we'll want to do is we'll want to make sure that the areas that we've analyzed are saved for later use. And we can do that using the analysis manager in our software. But the biggest thing is you want to find some way to make sure that this area is something that you can always go back to and make sure that the selection you've made corresponds to the proper number of loops, or corresponds to the right area or the right animal model based on the data you're trying to acquire. So to save this in LabChart, what we'll do is save it with the analysis manager, and you can find that here in the PV Loop workflow as well. The workflow is really nice because it's designed to keep all of the different features that you're going to use while doing PV Loop experiments all in one place, and you can easily access them. To save this data, I'm going to click on New Analysis, and I'm going to name it Baseline. We'll call it Baseline 1 in case we have 3 or 4 sections of baseline we want to analyze. Next, what we're going to do is we're going to try and analyze a section of occlusion. And this is a very typical intervention that we'll use, the vena cava occlusion, to stress the heart. And we get a different set of parameters when we analyze that. When we make a selection with occlusion data, we'll want to make sure we're selecting the transitional areas here, and so that way we'll get nice slopes, and just the changing areas will give us the parameters that we're interested in. Again, with the analysis type, we'll change that to occlusion, and we'll click Analyze Now to analyze that data. And you can see that the results are fundamentally different. First, we have the loop view providing us with changing loops. The loops are lowering in pressure, and they're moving off to the left, and that indicates a good change in our preload or our venous return, which is causing the stress to the heart, giving us the parameters we're interested in. These parameters in the loop view, the ESPVR and the EDPVR, are the key features that we're going to be looking for. And of course, all of this can be exported. So with the loop view and the ESPVR and the EDPVR, it's key to note that you'll probably want both the plot as well as the regression values for reporting those in analysis, and using those later on in your statistical analysis. So in order to access those parameters, you can simply select the view that you want to export, and then you have the option of exporting. If you go to Edit, you can copy the loop, the PV loop view, which is this plot right here. That'll copy the image of the plot. We'll also copy the loop view regression, which will copy the equation of interest and provide us with the results that we're looking for. We can export that and use those later on. Next, we also have the plots. We want to make sure that for each of the plots that we're looking at, our R-squared values are within the range that we've designated as proper for quality results. So all of these are pretty good. You can see we're at 9.7, 9.8 in terms of our R-squared values. And we have the preload recruitable stroke work, which is an important indicator of contractility. We have stroke work. We have pressure volume area versus end diastolic volume. We have pressure volume area versus end systolic pressure. We also have a couple other plots as well that don't pop up here automatically. These 4 pop up when we're choosing the occlusion data. But what we want to make sure you know is that there's a few more you may want as well. dPdt max versus end-diastolic volume is another. One last thing to mention here is that there are a few more parameters in the hemodynamics table that are available to us when we do an occlusion analysis. If we open up the hemodynamics table, we can go to the options, and you'll notice now that pressure, volume, area, potential energy, and cardiac efficiency are available to us. And those are things that are only going to be necessary for analysis when we're doing an IVC occlusion, and therefore they become available. When we're doing a baseline data, those are going to be grayed out. Again, you can export the data by going to options, you can export the data by going to export and export that data as text. You could do your statistical analysis later on. And the last thing is we'll want to save this data, again, because after we've done our analysis and even done our batch analysis or our group analysis, we will want to be able to come back to this data and review it later in case we want to add a parameter or we want to do anything else with it, or even just review and see where it came from. So that's a good summary of what we want to do with our data in pressure volume as well as the other applications, blood flow, blood pressure. Hopefully you've been able to get a good idea about the important aspects of what you want to accomplish when you're analyzing your data on the back end, and hopefully this will set you in the right direction to acquiring quality data and analyzing quality data and using that in your laboratory. I'm sure I'll be available if there are questions. Thanks for watching.